Dear students, just I am going to show you some objects. See these objects? See it carefully. Now tell me whether all these objects are same or they are different. You will say that they are different because one is diamond and other one is graphite and the third one is fullerene and fourth one is graphene. These are claiming as different because they appear in different ways, but chemically speaking, all these substances are same because in all these substances we have only one element, that is carbon. Why there is so much diversity in the appearance of these compounds? See the diamond. So how beautiful it is, how glittering. And see this graphite, it is black in color. Of course it is also shining, but it's black in color. It is not transparent. But these two, if we compare and see this graphene, this is also transparent, very light, and this is flexible and foldable and elasticity. So these are, all these substances are seems to be different from one another, but chemically all of these substances contain only carbon. Now let us see what is this phenomenon. So this phenomena is called as allotropy. Allotropy means the existence of same element in different physical forms is said to be allotropy. What is allotropy? Allotropy is a phenomenon in which same element will appear in different physical states. So here, when you observe these objects carefully, there is no relation at all. One substance is black in color and one is shining, glittering, and this is precious, and some other thing is very flexible, but we are claiming all are chemically same. This phenomena is called as allotropy. Why this allotropy is possible? This allotropy is a fundamental property of nonmetals. The fundamental property of nonmetals. This allotropy nature is exist because the difference in the arrangement of different atoms belonging to the same element in a different pattern. Now let us observe how these things are obtained. We know that carbon is in forms compounds in three types of hybridizations. In our previous classes, we have already discussed this. They are sp3 hybridization, sp2 hybridization, and sp hybridization. Now, in these compounds, we are going to see only two hybridizations, that is sp3 and sp2. Now, first let us discuss the structure of diamond.
In diamond, each carbon is in sp3 hybridization. Each carbon atom is bonded with 4 other carbon atoms to make a tetrahedral shape. Each carbon in this tetrahedral form bonds with 4 other carbon atoms, and such 3 tetrahedrals together forms a 6-membered Perkilled ring structure. This in terms a huge tetrahedral. The repetition of these structures makes a huge cage-like structure, that is diamond. In diamond, carbon is in sp3 hybridization, so the carbon-carbon bond length is 1.54 angstroms, and the bond angles are 109 degrees 28 minutes, and the bonds are so strong. Hence, carbon is considered as the hardest known substance in this universe.
Graphite. It take part into sp2 hybridization, and each carbon will form 3 bonds with adjacent carbon atoms like this. This is one carbon and this is one carbon and this is one carbon. So, each carbon will form 3 bonds. Now, again this carbon can form 3 bonds to form a hexagonal ring. Like this, a layer-like structure will be formed. Such so many layers, one layer by one layer, one layer by one layer. And within these layers, there will be no chemical bonds. That's why they are slippery in nature. That's why it appears in black color and it is slippery in nature. Because see, here we have a bunch of papers. So here, if these papers, there is no bonds between one paper to other paper. See, they can slip like this, easily slip. They are slippery in nature. They won't stick on to each other. They will just, in graphite, each layer will be bonded like that. But within the layer, if you take within the layer, the bonds are very strong. Within the layer, the bonds are very strong. In between the layers, there is no bond. That's why they are easily slipped. But within the layer, they are strong. That's why, though it is used as a lubricant because of its slippery nature, its boiling point is nearly 2000 degrees centigrade. The high boiling point of graphite is because of the strong bonds within the layer. The slippery nature is because of the weak inter
In graphite, each carbon is in sp2 hybridization to form a layer-like structure. Such infinite layers makes graphite. There will be no bonds between the layers, so they are slippery in nature. Hence, graphite is used as a lubricant. Graphene. Graphene is another important allotrope of carbon. It can be considered as single layer of graphite. It is transparent, flexible, and flexible. Graphene is 200 times stronger than steel and 300 times more conductive than copper. It was used in solar panels, touchscreens of cell phones, and many other household articles. If graphene is folded like a cylinder, we get nanotubes, which are another important form of carbon. Fullerenes. These allotrope of carbons in which carbon atoms are in a spherical shape. C60 fullerene, we have 6-membered and 5-membered carbon rings. Particularly in C60 molecule, we have 12 5-membered rings and 20 6-membered carbon rings which arranged in a spherical shape.